So in this video, it's a word problem dealing with projectile motion. We can read here on the monitor. A baseball is thrown at an angle of 25 degrees relative to the ground at a speed of 23 meters per second. If the ball was caught 42 meters from the thrower, how long was it in the air and how high did the ball travel before being caught? It's important we state what we're looking for, right? Usually the last sentence or last two sentences in this case. How long was the ball in the air? Well, if we're talking about how long, then we're talking about time. So I wrote time. And again, that little triangle is delta, which means change in time. So the time, in other words, how the time it took for this projectile to start and end. Okay. In some cases, this delta is omitted, just so y'all know, and it would just be time. So just to keep everything consistent, I'm gonna include the delta. Okay, and delta y max, and I'll explain why this is the variable for how high the ball traveled before being caught. So here's my little diagram of the thrower and the catcher, the ball going in its trajectory. And we know with projectile motion, it's parabolic. So that means at the highest point would be right in the middle of this, let's say, graph. Okay, so the distance it was at this point in this amount of seconds is the same on the other side. Same distance. So it mirrors each other, in other words, symmetrical. So with that in the back of our minds, if we look at this trajectory and we read these problems, we see that it was launched at an angle of 25 degrees. So I'm gonna draw a little imaginary line here, dotted line, black line, that goes from the height that it was thrown to the height that it was catched. Let's say it was level to the ground and it's parallel to the ground. Once it is launched, the thrower launches the ball at a 25-degree angle. So I wrote that here. And if we're talking about angles, then we're going to be talking about theta in terms of variables. Okay, we have 23 meters per second. Well, meters per second is going to determine speed or velocity, right? And hey, look, we have velocity. So yes, this is initial velocity because it was launched at that speed. And lastly here, 42 meters. 42 meters between the thrower and the catcher. Now, that would be displacement. So it would be from the position that it was thrown to where it was caught. Find the difference, right? So delta x, or should we put it here right next to it? Delta x. And I know it's delta x and not delta y because we're looking at the horizontal displacement, not the vertical displacement, which is y. Okay, so now that I've listed my variables here, I'll look at the two equations that we use for projectile launched at an angle. Okay, so I'm going to check off the ones that I have already. So I have velocity, I have theta, degrees, and then displacement with time as our only unknown. which is perfect, we can solve. So that's the equation we choose. And what I like to do is go ahead and solve for time first and then plug in. So if I have velocity times cosine theta times time, for me to isolate time, I'm going to divide everything or both sides by velocity in cosine theta. Therefore, that becomes 1, this becomes 1. I'm left with just 1 times delta time equals displacement over velocity times cosine theta, which is stated here. Then I go ahead and plug in the values. Well, displacement is 42, we have velocity 23, cosine, and then my degrees, which is 25. When you type this in, you find out, or we find out, that time equals 2.015 seconds. And it doesn't state to round to a certain place, decimal place, but I went ahead and chose thousandths place. Okay. Now, if you're not getting this answer when you type this in your calculator, it's probably because you're not using proper calculator syntax. So I have this little section here that's a reminder of how to type this in our calculator. If you have a Casio are one of the easiest to type in. It will understand if you write 42, / in it as the division. It also has the option to make it an actual division that looks like this. It has a ready-made button on these Casio calculators. Texas Instruments doesn't have one readily available, but I believe you can if you look through your settings and stuff. But with Casio, you can just go ahead and, 23, and then we have cosine, thinking about my y, cosine 25. The 25 is gonna have parentheses. We close them, and you should get the right answer. Now with Texas Instruments and all the TI family, they're a bit more complicated. It would definitely look like this, 42 divided by, and then when you follow, you have to open parentheses, then write in 23 cosine, then it's gonna open parentheses again. You're gonna write a 25, close parentheses for that cosine function, and then close parentheses again, one last time, to indicate I want 42 to be divided by all of this. Okay. If these parentheses at the beginning and at the end of your denominator is not entered in a TI scientific calculator, it won't give you the right answer. So if you have another type of calculator, let me know. Reach out to me, and I can try to help.